All right.
I forgot to pick.
Today in life, we are going to do more with the chain rule. So when we're taking, huh?
Is that what we did yesterday?
For the most part. So dy dx, that's the derivative of y with respect to x, equals dy du times du dx. And if you want to use the other notation, if I have if my function is f of g of x, then it's g prime of x times f prime of x, basically. Same idea. I like this better, just to make sense. Alright, so let's get these up. If I want to take the derivative with respect to x of sine x, that's cosine. We're going to want to memorize that. And if I want to take the derivative of cosine with respect to x, that's going to be negative sine. And if I want to take the derivative of tangent, that's going to be secant squared x. And if we want to take the derivative with respect to, if we're doing like an exponential function, like something like this, a to the x, that's going to be natural log a times a to the x. So just each day we'll add a few to memorize. So this is memorize these. Do not expect that you can get by without memorizing them. So now we're going to use the chain rule, apply it to this. So let's say y equals sine of 3x squared plus 7x plus 5. Now I want to find the derivative of that. So I'm going to name u, and u is going to be 3x squared plus 7x plus 5. That means my function is now y equals sine of u. See, all this stuff, all this extra stuff that's in this inside. Then, the derivative of y with respect to u is cosine. And then the derivative of u with respect to x is what from yesterday?
Negative sine?
No, I'm right here. U.
Oh.
Derivative of u with respect to x. 6x plus 7. Okay? Now, I have dy dx equals dy du times du dx. So this is what I just calculated. That's cosine of u times du dx is this. So times 6x plus 7. And then I replace my u back. And I'll put this in front because it's a coefficient. So 6x plus 7 times the cosine of 3x squared plus 7x plus 5. So I put my u, I replaced my u back to the way it was, and that's my derivative. So the whole idea is find that innermost thing. Like, it's kind of like when we were decomposing functions. That's how you use the chain rule. Alright, let's say I have the tangent of cosine of x. What would you let u equal? Cosine x. U is the innermost thing, the thing that makes it complicated. And what will be, then this should be y equals. Then y equals tan of u. Now what do we do?
Equal secant squared.
I take the derivatives of both of these. So dy, du. This is going to be secant squared u. And then I find du, dx. I take the derivative of that, what do I get?
Negative sign.
Negative sin x. Now, dy, dx is the product of these two. So negative sin x, and just to save us some extra work, I'm going to replace u right away. U is cosine x. So the power of these derivative tricks or formulas is that things that would be very difficult to do with the definition of derivative, which by the way, certain people who forgot that, just kind of side note, definition of derivative, we need to get that rule correct. It's the limit as h approaches 0 of f of x plus h minus f of x. So you have two pieces there you have to evaluate divided by h. You don't forget this, because you might come across something that we won't have a derivative rule for, and then you would have to revert back to this one. Okay? Next example. Let's say we have 3 5x cubed plus 2x squared to the 5th. Y equals. What would you let u equal?
X cubed plus 2x squared.
Yep. Which means all of this becomes
Y equals 3 to the fifth.
Yep. Now, what do I do?
Derivative.
Derivative of y with respect to u. What do we get?
15u.
Yep. And derivative of u with respect to x.
15x squared. 4x.
Yep. And then dy dx equals, I multiply these two. So 15, I replace u with what it is. And then I'm not going to expand this out, but I think it's reasonable to say I could take this 15 and multiply it by this to make things a little bit simpler. So 15 times 15 is what?
30. 15 times 15. Sorry. I was like, why is he asking this? 225.
So we have 225x squared plus 60x times 5x cubed plus 2x squared to the 4th. We won't expand that, but any multiplication that we can do rather quickly, relatively speaking, we'll go ahead and do. So that is our derivative.
Don't you do it? And not. Oh.
Okay. Next question is find the equation of the tangent line at x equals 3. And let's say our equation is 3 sine of 2x cubed. Yeah, that. So, to find the equation of a tangent line, we are going to need our point-slope form. And I would recommend right away we find y, because we need an x1 and a y1. So we need to find y, so we replace x with 3. Now, we would be in radian mode for this, so make sure your calculator is set to radian mode. Okay, so now let's evaluate. Y equals 3 sine of 2 times 3 cubed. So y equals 3 sine of, this would be 27. 27 times 2 is 54. So in radians, I mean, I know that looks like degrees, but we are in radian mode. What do we get?
Negative 1.6.
Okay, so now I put those into my x and y. M I'm going to calculate in a moment. Hopefully we're not lost on this, we're just finding our point. This is our point on our graph. Now, in order to find the slope, see I'm missing the slope, and just like with definition of derivative, I need to find the derivative of my function and see what it equals at 3. So I need to find dy dx, because that's going to be my slope at any point. So, to do the derivative of this thing, I'm going to need to use the chain rule. So to use the chain rule, I need to find u. What is u going to be? Okay, then y is going to equal 3 sine of u. Now we have a problem here. I don't know if you can see this problem, but this is more complicated than just a sine, right? I have this 3 up here. And that's going to be a mess, so I'm going to need to use something that's new. I'm going to use the product rule. So I'm going to come back to this slide, and I'm just going to show you the product rule. Product rule. This is a situation where we have like an f of x times a g of x. We have two different things and they're being multiplied. So let's say our function is h of x. If I wanted to, and I have the product rule actually written on the board over there. If I want the derivative of this, I'm going to first take the derivative of f of x and multiply it by g of x. Then I'm going to add to it f of x times the derivative of g of x. So I do them in two different pieces. So as an example, let's say I had x times sine of x. Okay, that's similar to what we have right now. So I have this function right here being multiplied by this function right here. I have two different ones. Now, you can choose them to be whichever you want. It's just going to need to make sense, but I hope you see the separation there. So, my dy dx, so this is my dy dx, I don't have any u's or anything, is going to be the derivative of x. So what's the derivative of x? We're stumped. So let's review that power rule. If I had 3x squared, what's the derivative of that?
6x.
6x, okay? So what's the derivative of x?
1.
1, okay? I have a power of 1, it comes out to the front. There's a 1 right there. 1 times 1 is 1. Then this decreases by 1. So it's a 0, and anything to the 0 power is 1. So the derivative of x is 1
I'm just trying to figure
times
out.
the second thing plus the first thing, okay, my x times the derivative of the second thing. So what's the derivative of this thing? The sine.
Sine.
Derivative of sine is
Cosine.
cosine. Okay, so my answer, dy dx, is going to be sine x plus x cosine x. Let's try one more. Let's say my problem is y equals 4x to the third times tangent x. No use or anything, because this is not, I hope you're understanding, this is not inside of the tangent. So it's not something I would use the chain rule for. So I'm going to use the product rule, which means, look at the product rule. I take the derivative of the first thing times the second thing. Then I take the first thing, derivative of the second thing. Okay? So this is my first thing. This is my second thing. Alright? So, dy dx. I take the derivative of the first thing. That's 12x squared. Times the second thing. Now I add to it, I do the first thing times the derivative of the second thing. And that is my answer. Okay? So, sometimes we have to apply rules within rules. So I have a product rule right here. So I'm going to go ahead and apply that product rule. I'm finding du dx, and I do the derivative of the first thing. Well, what's the derivative of a 3?
No, nothing?
0. The derivative of a constant, just a number, is 0. So I have 0 times the second thing plus the derivative, or the first thing, times the derivative of the second thing, 3 cosine.
I can't keep switching examples.
Okay, I said we were coming back to it. We just finished this one. Okay, we finished that. We're coming back to this one to finish it because we needed the product rule. So dy du equals, that's going to be 0, 3 cosine u. Then du dx, I take the derivative of that, 6x squared. And then for dy dx, my final answer is the product of these two. So that's going to be 3 cosine of 2x cubed times 6x squared. Note that this is not inside, it's not the argument of cosine. So I could multiply these two things that I underlined, so I get 18x squared cosine of 2x cubed. That's my derivative. Now I want to evaluate that derivative at what point? I'm trying to find the equation of the tangent line. I need to evaluate my derivative where? At what? Okay, yeah, I have an x there. What point specifically, though? I'm finding the equation of the tangent line at 3. So I evaluate my derivative at 3. Come on, guys. Alright, so the slope of my tangent line is going to be 18 times x squared, so that's 9, times the cosine of 2 times x cubed is going to be 27. So I'm just going to work this down. What's 18 times 9?
162.
And what is 162 times the cosine of 54?
Negative 134.35.
Okay? So that's a pretty steep slope there. There it is. That's our answer. We need to not get lost in all these steps. We need to remember our goal was to get the equation of the tangent line at a certain point. You can't lose that certain point through all the work. We found the derivative, but we were not done at that point. We needed to find it in order to get the slope. We'll do one more example of that. So again, find the equation of the tangent line. Let's say at x equals -2. And let's get our function. Let's say it is 3 times two x to the 4th minus 3x squared squared. Okay, what do I need to use the chain rule?
Yes.
Okay, so what's u?
2x to the 4th minus 3x squared.
Which means y equals 3u squared. What's the derivative of y with respect to u?
6u.
And what's the derivative of u with respect to x?
8x to the 3rd cube minus 6x.
Okay? And then my dy dx is going to be 6 times u was 2x to the 4th minus 3x squared times this 8x cubed minus 6x we could multiply that out. 12x to the 4th minus 18x squared. See, I distribute this into that first thing. And we could expand that, so why not? What's 12 times 8?
96.
Okay? And then 12 times 6 is 72, so minus 72x to the 5th. 18 times 8.
144.
And then plus 18 times 6.
108.
These are like terms. What's 72 plus 144?
216.
All right, we are evaluating this at what point?
-2.
Okay? So we put that in our calculator. We compute it. Oh, I get negative 6,240. This is what happens when you just make up.
Negative?
Yes.
I got positive.
You got positive.
It's an odd number, so it would be negative, right?
This will be a negative x. This will end up being positive.
Crap, I didn't do negative 2 to positive 2.
He needs a helmet so bad. Internet, Ryan needs a helmet. Alright, so we need to find the equation of the tangent line, so we go back to our point slope form. We never calculated what point we're at, so we really should have done that first, so all we had to do was plug this in. So we plug in our negative 2 into the original function to figure out, well, what is the point that we're at. So we'll do that. So 2 times negative 2 to the 4th minus 3 negative 2 squared. We're finding squared. What this is minus 1,200 by putting this negative 2 into here to find the point that we're at.